Okay, this week we will finish off the lab that we started in week 8, and here we will actually be using this to forecast. Now in order to do that, we need to add in a column. We need to add in a time column. So, whoops. Right click, insert, entire column. Time. Now, like we did in one of the early regression ones, we figured out how to do centered time. So we have 142 data points. 142 data points means that we divide that by 2. That's 71, subtract a half, so negative 70.5. Then negative 69.5. Highlight those, double click there, we'll send the pattern all the way down. Go down to the bottom, you will note at the bottom 70.5. 70.5 is the absolute value of negative 70.5. That's good. So now we click on data, data analysis, regression. We are going to be using time to be the only predictor of sales. So since sales is the input, the X variable, oops, I accidentally included the date. I only meant to include column B. Labels, worksheet regression, residuals, residual plots, line fit plots. Now I misspelled regression, so I'm going to right click on that, hit rename, get rid of the T. What I want you to do is look at these plots and you spread it out. Notice that in both of them we have a distinct pattern. Obviously an autocorrelation problem. But why is that? The autocorrelation is caused by the seasonality. So you would expect that we would have that. We may even have a slight heteroscedasticity problem. Notice we only explained 13% of the variation, 14%, but we explain it quite well. Why is that? Well, we have seasonality, which is not being taken care of. So I'm going to copy these two by doing Control C. Go back to the original data. Control V. Then we do a column called trend. Trend is just going to be straight prediction as if it was a regression. So this is going to equal the intercept plus time times the time variable. Double click on that. Oops. Slight problem. We need to make the L's fixed references. So I'm just going to type in $signs there. You don't want B to be a fixed reference. Copy that down. I'm going to drag it down. That is how much you'd expect to sell each period if you had no seasonality. If you compare it to the CMAs, Certain Moving Averages, they're pretty close. Not always the same, but close. Now right-click, insert another column, forecast. This is just going to be the trend times the RSF. Remember, when we seasonally adjust, we divide by the RSF. Well, in this case, we're putting the seasonality back in. So if getting rid of the seasonality is divided by RSF, putting the seasonality back in is multiplied by RSF. Take that, double click on here, that copies the formula down. Now what we can do is we can extend this. Take these two, drag it down, Control Z. You have to do a full year's worth. Well, November 2011, December 2011. Then you can highlight all of this, drag that down. Check to make sure that it did it correctly. It did. Take your time variable, extend that down. Take your trend variable, extend that down. The RSF we need to extend down, and this is column G. But remember, what we do is we say that that November equals the November above it, which is up there. And they put the TSF in because they think I want to do that. It's not necessary. Copy that down. So now we can take this formula and copy this formula down. We're going to verify that our forecasts are accurate. So I will highlight the forecast column, go to Insert, go to Line Graph, choose Line Graph, and it puts it in a bad place. Move this over. Move it up so I'll be able to find it easier. Probably could have just copied and pasted. It's taking a while, but it will get there. Okay. Now right click on it, select data, add data. The series name is going to be sales. Series value is going to be all those values for sales. And then edit the x-axis. That's going to be the dates. You notice I'm not including the word date. Okay. Now really I should also add labels for the axes. But let's make this a bigger graph. Notice, well, there are a few exceptions, like there and there and there and there, but for the most part, the sales are almost exactly a perfect fit for forecasts. I mean, yes, so the forecast does a great job predicting what the sales are, even though when we ran the regression, we got small values for the adjusted R squared.